Hello all, good evening. Very warm welcome to this class. So once again, Happy New Year to you all. So I truly appreciate for all of you in time to be here and showing your interest to learn something new at the beginning of this year. So, welcome you all. So we will proceed further. So any question before proceeding further, guys? Okay, no questions. So I will. Most of the learners are new in this today class also. So I will brief about this yesterday class, guys. Yeah. Okay, great. So I will just brief about the what are the topics we have covered yesterday. So we'll proceed further. Okay. So let me share my screen. Yes, we have shared the right yesterday recording over the WhatsApp group. Yeah, you can find over the WhatsApp group page. Okay. Yeah. So we'll get started. So let me share my screen. Okay. So I hope my screen is visible, guys. Yes. Okay, it's visible. Okay, great. Okay, thanks for confirmation. So just I will walk you right. What are the things we have covered yesterday? So we understood, we try to understand. So this is the 3 day sessions, right? Here we try to understand what is the AI, what are the different branch of AI, right? So what is the large language model in the study sessions we understood. Then hands-on practice also in the different LLM models, right? From the Grok. So today we are going to understand this AWS and Open and Gemini platform, how we can integrate the different LLM models. And we started integrating, utilizing the SageMaker and Bedrock services, right? So today we are going to discuss the RAG architecture and project building using the RAG architecture. And day after this tomorrow, right? So tomorrow we are going to see how we are going to build this and deploy this project in the Azure cloud. Okay. So this is the agenda. And in this, right? So yesterday we learned what is the AI, right? So AI is nothing but the artificial something we are making some synthetic or artificial, right, intelligence. We are applying this intelligence the machine, right? So I understood, right? So it is a the machine we are making the machine or systems that can be think, learn, right, and make a decision like a human. So ability to machine to mimic the human intelligence, right? So there we understood what are the different branch of AI, right? So here the subset of AI which helps in making the decisions, making the predictions. We can generally call it the classical AI or traditional AI, predict AI, right? We are making some decisions, predictions, classifications, right? So by learning the data patterns, right? And here we have this different types of AI in the topics it covers on this traditional AI, machine learning, natural language processing called NLP, deep learning, some statistical and coding as a Python, right? Then we understood the second branch of AI, the which helps in creating new content, right? Generating something new, right? So that is called generative AI. In the generative AI, we are creating some new content. Okay, that can be text, that can be code, that can be image, audio, video, right? So with the help of different LLM model, we are going to understand. And then another branch of this AI, right? So which helps in making thinking, planning, action. We can call it the agentic AI, right? So here we are how we are going to understand what is the AI agent and agentic AI frameworks, right? So different frameworks will be there: LangGraph, LangChain, FreeAI, Epigen, Agno, PyData. Okay, so this will help in for this creating and building this agentic AI ecosystem. Okay. After that, we try to understand what are the LLM models. Okay, before getting into the LLM models, we understood what is this language model first of all. Okay, so we understood what is the language model, how we can helpful for to understand these different languages, different words, its syntax, grammar, word level, local meaning of this word, global meaning of word, the context meaning of the word, right? We are going to understand, we are going to train this machine so that it can learn this all these patterns of this given language. And for this building, we are going to build some of the algorithms, right? We are going to some algorithms. Okay, we are going to train this machine so that it can understand the grammar, word meaning, context, relation between the words, and so that it can predict the next word and the filling the blank. Okay, the mask word. Okay, we can say. So this how we understood the language models. There are the different types of language models. N-gram based statistical language models are there. On top of this, we understood what is the large language model is. Okay, large nothing but the we are training this language model on the very large corpus. That corpus is the millions, billions, and trillions of parameters. Okay, so those datas are we are utilizing for training purpose. Open books data, guys. Okay, books, Wikipedia, articles, right? The code, public forums, right? So all the data we are going to provide to the LLM model to understand, and based upon that understanding, so it will going to learn different languages, different patterns of the different languages, different grammar, syntactical structure of the language, right? All these things it will going to learn, right? And based upon the learning, it will try to while learning, right? So we are going to so we are training this large language model amount of huge amount of data using the deep learning transform architecture. We'll understand what is the transform architecture. There is the encoder and decoder part, but decoder is utilized for this, right? Training for purpose this of LLM models, and then we can understand. Okay, this is the language model is in the language model plus we are providing the large data plus deep neural networks, right? For creation of this language large language models, and in this we understood, right, how these language models are trained, right? So this is the language models are trained with the help of some pre-training techniques. The resultant model will be foundation models. Then we understood what is the SFT supervised fine tuning. We are providing the label data to train this LLM model, right? And then along with it, we have provided this reinforcement learning, means human feedback to LLM model to understand the human preferences for the particular question, right? Particular answer. What is the which response is the most preferred for the as per the human response, right? As per the human's perspective, right? So these are the pre-training techniques. Generally, we these LLM models come up with this, and whenever we want, right, downstream application, whenever we are going to fine tune as per our domain specific, then we are going to custom fine tune now LLM models using this uh, PEPT, right, parameter repetition fine tuning, LoRa, QLoRa. Okay, so this is how we just understood this, how we can uh, understand these LLM models, how can train these LLM models, and what are the capability of these LLM models, right? So this LLM model can understand the human intent, user language, human language, generate the new content. We can use it for the question answering, content writing, translation, summarization task, okay, research work, right? It will adapt the tone as we are given the tone, right? So as per the role style, it will going to accommodate and it will going to work accordingly. Okay, so that is the beauty of this LLM models. Okay, then after that, we start learning. We are going to start this today, RAG architecture. Okay, before get RAG architecture, so I will showcase how we can implement, integrate these LLM models. Yes, yes, yes. I have shared this document, guys, in the WhatsApp group. Okay, I have shared with the team. Okay, team will share in the WhatsApp group. Okay, so do join the WhatsApp group. You will get this. Okay, this documents notes over there. All right. So now we'll proceed. Okay. So yesterday, what we did, so we have created this AWS account, right? And we have started utilizing this AWS SageMaker services. Okay. So here, AWS console login. If you go to the AWS console login, right? So I have provided one document here. How can log in, right, to the AWS account? Have you tried, guys, this login? Have you tried to set up your account? Yes, no? Okay, great. Okay, yes. So any challenges? Okay, please refer this document. Okay, so you are doing great, guys. Okay, really appreciate it. Okay, so now we can see once this our account is set up, right? So we are going to utilize this. What we did, so we are start utilizing the SageMaker AI Studio. Before we get into SageMaker AI Studio, okay, okay, sure, sure, I will share this document again today. No worry. Okay, how can create this? I will share it again. No worry. So guys, see, okay, before getting into this, right, AWS SageMaker Studio, what we did, so we have created this IAM role. Okay, IAM role, we have created this user. Okay, we have created different user right here. So we can create this different user, right? And in the user, we are providing the username, right? Mahesh, we are going to create this username. we are going to attach directly policy, right? We can directly assign the administrative access. As of now, as right, we have this our account, right? We can provide the administrative access, whole access, right? But in the industry, what we'll do, so we are going to provide some user group or copy permission. Okay, just I'm copying the permission from this user to, okay, which how we are providing the access of AWS SageMaker full access and Bedrock services full access to this user. Okay, and this how we are going to create this user. Okay, this user is created, as you can see this new user is we have created. And how do we create this API key, right? So you can see here the create API access. So you can see I'm going to utilize this running over the AWS compute service. I'm going to click on understand and next. Okay, so create access key, right? So this how we have created yesterday, this AWS access key and secret key. So this key will be utilized, guys. Okay, this key will be utilized for our accessing of this different AWS services, right? So this key we have to store, right? I have stored this key here. Okay, .ini file. You can see here I have stored this access key and secret key. I have stored here. Yesterday I have stored this key. Okay, but I have shown this today also how you can create. Okay, so you can download this key also. Okay, later part we can refer. We cannot see this after, right? So that is the reason you can download and save this, right? You can store in the safely places. Okay, so now after this, what we learn? So we go to this AWS SageMaker, SageMaker AI. Okay, and the SageMaker AI, we understood this. What how we can create the notebooks? Okay, how we can create the notebook? Now how we can create the SageMaker Studio, right? For SageMaker Studio, we require the set up the domain, right? Initially, we have created the notebooks, right? You can see here. So we have created this notebook, right? Initially, yesterday, we have created this notebook. So you have to just create the notebook instance and start the coding, right? Using the notebook instance, okay? Like a Jupyter notebook, right? But yesterday also we saw how we can create this domains, right? So we have created different domains, right? These are the domains. We can create this domain. It will take some time to set up this domain, but yesterday we have created this domain. We will be utilizing same domain here, guys. Okay. So here, let me open this studio. Okay. So yeah, so this is the SageMaker Studio, guys. Okay, the SageMaker Studio. So here, what we'll do? So we are going to create the Jupyter Lab, right? So we are going to utilize the Jupyter Lab, and we are going to utilize the VS Code in the AWS SageMaker, right? So initially, yesterday we saw, right, what is the Jupyter Notebook? How we can create? Okay. So if you're not yesterday present, right, you can watch your recording, previous recording also, right? That will be helpful. How you can write in the code in the Jupyter Notebook, Jupyter Lab. But I'm going to showcase this VS Code, how you can utilize in the this AWS cloud, right? So this is the VS Code, right? So we have created, right? Yesterday we have created this session, one machine for this VS Code. So this is the quick start, right? We can launch this quick start. So it will create new VS Code, guys. Okay, it will going to create this. You can see the status is updating, and it will update and it will start creating, right? This the machine, right, at the backend, so that we can utilize this, right? So already we have created. I'm going to open this and start utilizing. Okay, so far any question, guys? Till now it's all good. Just I have provided the recap, right? Just I have provided the recap of this yesterday session. So any questions so far? Yes, guys. If you have any question, no, drop yours in the chat box. Okay. I will take your doubts. Okay, Yuvraj. I will give the permission at the last. Okay, no worry. Just if you have any questions, no, as of now, just drop in the chat box. Okay, that is fine. Okay. Okay, all right. So now we can see. Okay, so this is how we have created the VS Code. Okay, VS Code instance. And here we are going to open the folder to where we can write the code, right? So we have to click on this open folder, and here we have to select this .vs code server OS, because we are working on this folder currently. VS Code, we have to select the same folder, VS Code server OS. Yes, okay. So yesterday we have some work, right, around it, right? Yesterday we did some work around it. So I will just brief about this yesterday work. Okay, all right. So we have installed this library, right? Pip install Boto3. We have yesterday installed this library, right? After the installation this library, why we are installing this library, guys? This Boto3 client will be required to interact with this AWS, right, services, right? So we are utilizing this Boto3 client API to call with the AWS Bedrock services and AWS, right? So now we are going to install this python.env. Yesterday we saw, right, this how we can install this. Then after this installation, successfully installation, we are going to utilize from .env, load env. Okay, and this will load this environment, guys. Okay, in the environment means nothing but what are the keys we have stored, right? You can see in the environment file we have created different keys, right? This AWS access key and AWS secret key we have stored here, and this right, different API keys also we can create. I will showcase how we can create. Okay, as of now we have understood this three key we have created. Okay, and then we are going to store in the .env file, and then we are going to load here, guys. Okay, with the help of load env, so that it will load that all the credentials in the environment. Okay, this environment we are going to utilize, it will load in this environment. Okay, so now we are going to import this Boto3 client, right? And here, guys, in the AWS Bedrock, right, if you go to the Bedrock services, okay, AWS Bedrock services. Okay, so now you can see there is a model catalog, right? So this is the providing the lots of foundation models. Okay, different LLM models they are providing over here in the Bedrocks, AWS Bedrock, right? So how we can get, you can see here the different, this is the model catalog. Okay, in the model catalogs we have the different LLM models available. Okay, around, this is the 271 models, and these are the provider, guys. Okay, A21 Lab is there, Amazon is there, Anthropic. Okay, these are the different providers. Those are providing this LLM models, and these are the modality, means different tasks, guys. Okay, so we are going to utilize for the text purpose, some speech purpose, some image generation purpose, some audio purpose, right? So these are the different LLM models they have provided. Okay, so now we can see we are going to utilize these different LLM models. Okay, we can, here you can see the Amazon has provided some LLM models, Mistral, Nova series. The Anthropic has provided this Cloud series models, right? Then we have this Llama, right? Meta has provided Llama series model, right? So these are the different LLM models we have. I have created the list here, guys. Okay, so I have created the list of these models here. You can see this is the list of models, Amazon Titan, Nova series. Okay, and this Llama, Meta Llama models, we have this Llama 3.3, 3.1, 3.8 billion, right? Gemma series models also there available. Some Mistral series models also available. Some OpenAI, this is the open source model, right? From the OpenAI, GPT OS models. Then from the Anthropic, we have the different LLM models also. I have just provided a list here. I will share this documentation. Okay, so we'll get started right in the code, guys. Okay, so now you can see. So we are going to utilize this Boto3. Okay, so this is the model. We are going to use the model ID as a Amazon Titan Text Express. This is LLM model. Okay, and this is the region, guys. Okay, where we are accessing this model, right? So you can see here, this is the region, right? So this is the East US region one. Okay, so we are going to utilize this region for invoking this model. Okay, utilizing this LLM model. Okay, so this is the depend, right? Which region we are working or our client is working, accordingly we are going to prefer these models. Okay, according to that region. So as of now I'm just providing this East US because most of the LLM models are available in this region. Okay, so that is the reason I'm going to utilize this East US East one. Okay, all right. So then yesterday we saw, right, how we can set up this client, Boto3.client. We are going to set up this client through the API. We are providing the service name as a Bedrock runtime. We are going to utilize, and this is the region, which region we are going to utilize this service, right? US East. This is mandatory, guys. Okay, so this is the mandatory. Without this provided region, we cannot access this service. Okay. So then we have written some prompt, write a feedback email to the support team. Okay, and then message, right? In the message we have to provide the list of messages, guys. Okay, means here we are providing the list, and in the dictionary we are providing the role, means user is asking this question. The what is the user is asking, we are providing as the context as a one key, and in the value we are providing as a one dictionary, list of dictionary. Okay, and here prompt. Okay, so we are providing as a prompt in these messages. Okay, So now what you'll do, so we are going to invoke this model, guys. Okay, we are going to invoke this model to get this response from the LLMs. Okay. So here we have created this client Moto3. Okay, Bedrock Moto3 dot. We are going to utilize the converse method. Okay, converse. Okay, converse. There is a two method, guys. Okay, to invoke this model, there is a one converse method is there, and there is a invoke. Invoke is also there. Okay, so we'll understand the difference between this converse and inverse. Okay, invoke model. So we are in this, we are providing this message, guys. Okay, what is the message? Yesterday till this point we learn. Okay, so now we are learn in the front of, right? So message is equal to messages. Okay, so this is the message, guys. Okay, that this message is nothing but the user is asking this prompt. We are passing this while invoking as a message, and then we are going to provide the model ID, right? Which model we are going to utilize? So this model ID we have to provide here. Okay, model ID. We have created this model ID here, right? Amazon Titan Express model. As of now, we are utilizing. Okay, and so I'm going to store this response in the one of the variable equal to response equal to this one. Okay, so we got this some response. So let's print out the response. Okay, so you can see here. So we got this some dictionary. Okay, in the dictionary. So we are getting some output here. Okay, you can see we want this output, right? In the output, there is a message. In the message, this is the role is assistance. Assistance means we are getting the response from the LLM models. Initially, we have provided this role as a user. User is asking this question, but now you can see we are getting this output, and this is the output. We are getting the dictionary form, and from the dictionary we are getting the message. Then role of this assistance and content. We want this content as a text. Okay, so we want this message as output. Okay, so how do we access this? So you can see, guys, this is the dictionary, right? In the dictionary, this is the one key is there. How do you access the dictionary? Any idea? Anyone? You can see here, the response is there, right? So response, and we are accessing the key. How do you access the key? By its name, right? So this is the output. Okay, so in the output, we got another key, another dictionary, right? Another dictionary, we are getting the messages here. Okay, so let's access this message also. Okay, we are going to access this nested dictionary, guys. Okay, messages. Okay, then we can see in another dictionary is there, right? This curly bracket. The role is there, the content is there, right? We are interested in this content, not in the role, right? So this is the response we got from the LLM models. And then we are going to access this content. Yes. So we got this, right? List now. You can see we got the list. Inside the list, we got the dictionary, right? Inside, this is the list, right? Okay, square bracket means this is the list. Inside this curly bracket means this is the dictionary, right? So we can access this text. Okay, so you can see here. So now I'm going to access this 0th index. Okay, list how can I access by its index, right? Not by its key. We are accessing by its index. Right, we got the dictionary. Again, in the dictionary, we got the text, right? So we have to access like this. Now we are going to access this nested dictionary, nested list. Okay, so we are providing this text. And now we can see, guys, we got the response. Okay, so many, right? So we have to access the nested dictionary, nested list, and we got the response. Okay, this is the response from this LLM models. Okay, so we ask, okay, write one email, right? Write a feedback email to the support team. So it is given this response here, right? It is given subject, dear support team. It is given some response here. Okay, so likewise, we can access this LLM. Okay, LLM model from this AWS Bedrock service. Yes, yes, guys. We are providing this recordings. We are providing the WhatsApp group. Okay, you can join in the WhatsApp group so that you will get this access, right, to the recordings. Okay. Yeah. So now you can see we understood, right? So we have utilized one of the models, right? We have utilized the one of the models here, and we started utilizing the models, and then we got this response, right, from the models, right? So likewise, we can utilize the different LLM models, right? We initially we saw we can utilize this one of the models. There is a list, right? List of model guys. Okay, you can see here. I have provided this. Initially we have utilized this model, right? We can utilize this LLM model also, Meta, Llama. So let's utilize this model also. Okay, I'm going to change the model name only. Okay, so let me change the model name. Okay, reason will be same. Just I'm going to change the model ID. Okay, and here I'm going to change this model ID to Meta Llama. So this models available in the AWS Bedrock services, guys. Okay, just I have provided the list of this Bedrock services, LLM models from the Bedrock services. And here we are going to change this model. Okay, Meta Llama. This model ID I'm going to change. Okay, and then we are going to provide a message. Okay, message will be same, prompt will be same. Just we are going to this model ID, right? Response equal to. Okay, let me keep here message also. Okay, this is the messages, and let's write the prompt. Okay, again one more time. We're going to write the prompt. Okay, we'll change this prompt. Okay, as of now, we'll keep the same. Okay, we'll check the response. What is the difference between the response from the different LLM model gates? Okay, so this is the same prompt we are going to keep. The model ID we have just changed. The same message. Now we are going to invoke this message, guys. Boto3.converse. We are going to this message and model ID. We are just change the model ID, nothing else, guys. Okay, so we are getting this response. So any questions? Okay, AWS Bedrock LLM ID is same for, yes guys. Okay, you can see this model ID is same, right? All the reason model ID will be same, but in the some of the reasons this model is not available. Okay, model ID is same, guys. Okay, model ID is same, but some of the reasons this model, right? Some of the models are not available. Some of the reason model are available, right? Some of the reasons. Okay, let's suppose this is the East one. Okay, let's suppose I'm going to change to the Mumbai region. So they are some of the less number of models, guys. Okay, there are the 271 models was there, right? You can see there are 219 models. Means there is a 50 around, right? The 40-50 models are lesser here in this region, right? So model ID will be same, okay, but this model, some number of models will be some less or more, right? In this according to different regions. Okay, so that is one thing. Okay, so we got the response. So how we can get the response? We have to write this code to access this final response, right? So I'm going to access this. Okay, so now you can see. So we got the response, guys. Okay, so we got this email, right? We are asking this LLM. Okay, can you frame this right email? So initially, right, we have utilized this text titan model. Okay, it is giving some response like this. Okay, subject, some response, and some email is break here. Okay, in between it is break, means it is not completely given this complete email. Okay, so you are right sincerely in all this. Okay, but now you can see here we are utilizing the different LLM models. Okay, so we just change the model Meta Llama. Okay, 370 billion instruction model. Okay, so here it is giving this right subject, then the construct this body, then best regard, right? So this is the just example they have provided, right? So this is the different LLM model, guys. Okay, so these are the different LLM models we can utilize, integrate, and start utilizing. Okay, I will give this 2-3 example of this LLM models so that we can get the idea how can utilize this different LLM models from this AWS Bedrock services. So let me provide this another example from this Google Gemma series model. Okay, so I'm going to provide here Google Gemma series model, this model ID. Okay, what is the, okay, let me close this. Okay, this is the model ID. And then we are going to invoke this, right? Same message will be there, same prompt will be there. Just we are going to invoke this model. Okay, same question. We are going to invoke, and then we are going to print the response here. Okay, so we are going to get the response. far, any question, guys? So far, any questions from anyone? Any part you not understood? No? Okay, all right. Okay, you can see we got the response from this LLM model, right? We got the response, right? Here's specific subject line, specifics, then reference, right? Contact information, be polite and respectful. It has given one example also, right? If you scroll down, we'll get this complete example. And this is providing some reminders, right? It is providing some instruction about this, right? Yes, guys, we'll, right? Yes, we can change the role of user, right? If you role of user change to assistant, okay, what will the response? Okay, so this guys, okay, you can see here, we are providing, right, LLM models, right? So this is the user role, no? Initially, we are providing this user role so that this LLM can understand, right? This user is asking, right? So in that case, in case of few shot prompting, guys, okay, there is a one topic is there, prompt engineering. We are providing this user role. We are providing the assistance role, right? So user means user will ask some question, and we are providing the role to the assistants, and then we are expecting this response from the assistants. Okay, and then we are getting to some more questions to the LLM models, and we are getting the more answer from the particular new questions. Okay, as of now, we don't have to give this. Okay, the assistance role. Just we have to provide this user role because this prompt is given from the user, not from the assistants, right? So that is the reason we have to provide. Whenever we are utilizing the few shot prompting now, in that case, we are going to provide this user role as well as the assistance role. Okay, and then based upon that, it will going to understand what is the user is given the response, what is the AI assistance is giving the response. So we are giving some 2, 3 example. So the LLM can understand, based upon that understand, it will going to understand and it will give the response. Okay, so that is the benefits of providing the user role and assistant role for the few shot prompting. Okay, so we'll provide some instruction. We are providing some guidance to the LLM model. Accordingly, it will going to response. Okay, so this how we are utilizing different LLM model, guys. Okay, this how we are utilizing different LLM models. Now you can try out the different LLM models. Okay, you can try out the different LLM models. Okay, I will provide this list of these LLM models. You can try out this. Let's suppose we have utilized. Let's suppose we are going to utilize this Mistral model also. Okay, so we are going to utilize this Mistral model. Okay, this is the model ID. Okay, and then we are going to invoke this. The same message will be there as of now. We are going to invoke with the help of this new model, right? This is the new model, and we are going to print this response. Okay, the final response we are going to print. So we got the response from this LLM also, right? So these are the different LLMs. We can try it out. Okay, and we can see how the LLM is giving the response, right? So you can understand this different, which are the LLMs, how helpful, right? You can integrate. You can try it out different LLM models, right? You can try this OpenAI, Anthropic. Okay, you can try it out different LLM models. Okay, so this is how we can integrate this different LLM models and had some practice. Okay, so I will provide, guys, at the last, if the time permits now, I will provide the how you can integrate this Gemini models and this OpenAI models also, right? How you can integrate. Okay, so any questions so far? So we are moving to the RAG architecture, guys. Okay, now we are going to move into the RAG architecture. Any questions so far? Anyone? No questions? Okay, all right. So we'll understand this. What is the RAG architecture? Okay. So here, if you see, so some of the limitations, guys. Okay, LLM has the limitations. Some of the limitations of LLM. Okay, before understanding, go into the RAG architecture. Let's suppose this is the user query. I hope my screen is visible, guys. Yes, this one notepad. Okay, it's visible. Fine. Okay, perfect. So now you can see we are going to understand this RAG architecture. Before getting to RAG architecture, so we have to understand some basic things. Okay, so this is the user query. We are passing this user query to the LLM model. Okay, LLM model, and we are expecting some response from this LLM, right? We are expecting some response from LLM, right? So we are passing this user query, right, to the LLM model, and LLM is process this and get the response, right? It will try to complete this user query, right? It will try to complete this user query. Yes. So any questions? Yes, yes. I will going to okay. I will going to explain how you can deploy this LLM models. Okay, in the right, tomorrow class. Okay, today we are going to understand RAG architecture, and we are going to build one of the use case. Okay, exploration part, and then tomorrow we are going to build the source code, and then we are going to deploy in the AWS or Azure cloud. Okay, so tomorrow class I will going to showcase. Okay, just concentrate now, guys. Okay, I will give the time to answer your query, all the query. Just you can focus now. Okay. So now you can see, so we are asking some query to the LLM models and LLM is giving the response. But how it is possible? LLM is why it is giving the response? Because this LLM model is trained, right? This LLM model is trained on this large corpus, right? LLM model is trained on the large corpus, and that is the reason it is giving the response, right? This LLM models, we know, right? It is trained on the general data, right? It is trained on the large corpus. Okay, you can say large corpus, and that corpus we can billions, millions, on even trillions parameters, guys. Okay, even trillions parameter, it is trained this, and based upon that learnings, right? LM is trained on this different, like large corpus text data, right? Large corpus text, billions and trillions of parameter. So we are asking these different queries, right? Give me the email writing, give me some, right, some instruction, right? So we are asking different query to the LLM models, and LLM is process that input and it will try to generate the next input, next word, right, as output, right? It will try to complete that user prompt, user query. It will try to give the complete. It is synthesized. It will going to process and it will give the response as output. Okay, but now you can see this LLM has the some cutoff here, guys. Okay, LLM has this some limitations. What are those limitations of LLM? Okay, so there are some limitation. So here it will cannot access the real time. Okay, real time data or web, right? It cannot access real time information. Okay, but it can access the real time information. We have to provide some tools. Okay, but by default it cannot access by its own, right? Cannot access this real time information, or you cannot say you cannot browse this data. Okay, you cannot browse the internet data, right? Web data, right? We cannot browse the web content or web data. Okay, this is one disadvantage here. Okay, it don't have the capability inherently, guys. Okay, and then it cannot have this memory also, right? It cannot store this memory, right? It cannot store the conversation. Don't have any memory. Okay, by default. Okay, so now based upon this one pointer, first pointer, guys. Okay, based upon this first pointer, we are going to understand this LLM is not able to access this real-time information. Okay, but let's suppose I'm asking this. Okay, this LLMs are trained on some. There is a knowledge cutoff, guys. Okay, so you can see there is a knowledge cutoff is there. I can write this. Third point is the knowledge cutoff. Okay, what is this knowledge cutoff? If you see here, there are the different LLM models. Okay, let me go to the this LLM models, OpenAI LLM models. Okay, OpenAI models. Okay, this is the OpenAI models we have. Right, each model is having the, some knowledge cutoff. Okay, so you can see. So let's suppose I'm going for this GPT-2 5.2 models. Okay, and there is a knowledge cutoff. You can see here this August, right? August 31st, 2025 means this model is trained on before, right? Means before this August 25, right? This year means if you ask this any information before this August 20, right? August 25, it will give the answer, right? Because it is trained on the data. But let's suppose I'm asking this current information about this LLM, so it will not give the answer. Okay, it will not give the response. Why? because this LLM don't have this current knowledge, because it is not trained on this current today's date or last yesterday date, right? Because it is not trained on that is the reason it is having some cutoff. The model is trained till particular date. So particular date information this LLM model has, and beyond this date, this LLM model cannot answer this any information, because this is the limitation of this, right? This LLM model. So this is the GPT 5.2. Let's suppose we are going to the another model. Let's suppose I'm going for this GPT 4.1. Okay, so you can see the GPT 4.1 is the knowledge cutoff is the 1st June 2024. Means let's suppose I'm asking some information about this LLM, about the recent information. Okay, so it will not give the any response. Okay, it will give the response, but it will going to hallucinate. Okay, means after this June 24, I'm going to ask one of the question to the LLM model. It will give the response, but this response is not correct. Why? Because this LLM is not trained on this recent data 2025. This is trained on and before 2024 data. So this has the limitation. This is the limitation of this LLM model. You can say the knowledge cutoff. Okay, we are asking the recent information. It will not give the that correctly answer. It will give this answer, but it will give the incorrect response. Okay, that is the one thing we can call as the LLM should have the memory of its own, but it's having the continued conversation. It's my understanding correct? No, guys, see this LLM by default it don't have any memory. Okay, but you can provide this memory. Okay, to the LLM. Okay, by using this different for the storing the conversation for session specific memory will be there, or we can say some some temporary in memory will be there, or some long term memory we are going to provide to LLM so that it will understand in the conversation purpose, right? But it by default it not store. We'll verify this also. Okay, no worry. So now you can see. So we are asking this question. Okay, this LLM has the capability to produce the next word because it is trained on the billions of parameters, billions of text corpus, right? So we are asking this user query. Okay, we are asking this user query as a prompt to this LLM model. Okay, we are passing this LLM model, and then LLM will have the capability to generate the response, right? LLM has the capability to generate the response. Okay, and this response is nothing but what is the response? Okay, so let's suppose we are asking some recent knowledge. Okay, let's suppose what's happened in the December 25. Give me the recent, summarize the information about December 25. But it will give this information, but this information is not correct. Okay, so what is the benefits here? What is the disadvantage here? You can see LLM is going to response, but okay, you can see it will going to provide some answer with confidence. Okay, with confidence, and then we can call it the hallucination problem. Okay, this is called as a hallucination problem. Why we are calling is the hallucination problem? Yes, because LLM don't have this, right? LLM don't have the current knowledge, right? We are asking some knowledge. Okay, user is asking so about the current, right? The current right news. Let's suppose we are asking this current news. Okay, in the month of December. Okay, so we are asking the some current news information to the LLM. LLM don't have the capability to web search by default. Okay, we can provide this capability to LLM with the help of tools and agent. Okay, but by default it don't have the capability to search on the web, and it has some knowledge cutoff is there, right? So we are asking some right some information which is beyond its knowledge. Okay, so then in that case, it will going to provide the response because the LLM has the capability to predict the next word. So it will provide the response, and this response is the not correct. Okay, this response is the not correct, and we are going to call this as a hallucination problem. Okay, how do we solve this hallucination problem? Yes, then there is a problem, right? We have to solve this hallucination problem. We have to come up with some solution. Now, you can see whenever we are providing some user, we are asking this user query. Okay, to the LLM model. Okay, we are asking this query to the user LLM model, but now you can see. So what you okay? So what you'll do? We are just asking this user query, right? We are asking this user query. Okay, we are asking this user query, and along with this, guys. Okay, along with this user query, what we'll do? So we are providing some context. Okay, so we are providing some context. Let's suppose we are providing some context here. Okay, this is the user query. And let's suppose we are providing this current knowledge also. Current some of the information is happened. Okay, and we are providing this current news or current information. We are providing the context to the LLM model. So what will do? The LLM will understand the user query and the context according to that user query, and then it will going to generate the response. Okay, it will going to generate some response. Okay, so now we are getting this response. Okay, it will going to give the correct response. Why? Because what is the question is there. Okay, this is the question we asked initially. Okay, but this initially what happened? This element don't have the current context, right? The recent context. Okay, but now let's suppose we are providing some recent context to the LLM models. Then it will provide this, right? It will provide this. It will going to understand user query, and it will going to based upon this context. It will going to synthesize, and it will going to provide. And then this how we can solve this hallucination problem. Okay, this can we can solve this hallucination hallucination problem. But now there is a challenge, guys. Okay, there is a challenge. How we can provide the context? Okay, how we can provide the context? That is very important. Okay, so there is a context we can store. Okay, in the let's suppose I'm going to store. I'm going to provide as a tools. Okay, let's suppose I'm going to provide the tools also. Okay, we can provide this context with the help of tools. Okay, tools, or we can provide this. Okay, we are going to store the context somewhere, right? So we can provide one way is to we can provide this LLM with some tools, and then tool can interact with this, right? The data, so web search or some of the knowledge base, right? And you'll get the answer. But let's suppose I'm asking this user query. Let's suppose I'm asking this user query, the HR policy document gets. Okay, so let's suppose there is another query. Okay, and we are asking, let's suppose LLM is, we know, right? LLM is trained on the large corpus of the data. But for my organization, it is not trained, right? My organization data, private data is not trained. Let's suppose we have the HR department is there and HR policy documents are there. Okay, HR policy documents are there for particular organization. Okay, particular organization, we have the HR policy documents are there. And we are asking this user query to the LLM. Okay, LLM will not give this answer because LLM don't have the knowledge of this particular HR policy document. Okay, in that case, what will do? So LLM will give the response. Okay, but this was is the incorrect response. Okay, and it will give the in the very confidence. Okay, that is a hallucination problem. LLM don't have the knowledge of this HR policy document. It still it is given to response. Okay, general response, but and then you can this is response is not correct, right? So this is the hallucination problem. So what if this context, right? What if we are providing this context as a one store? Okay, we are providing as a one store means we are going to store this data. Okay, in the one of the memory, right? We are going to store in the one of the database, or we are in memory. We are going to provide as a context. Okay, so how we can going to store? There is a different way, guys. Okay, there is a different way to store this context, store this knowledge. Okay, I will take your doubt if any. You can ask. Okay, if you have any relevant doubt, no, you can ask. Okay, what does LLM is? Why? Okay, does LLM know it's a hallucination? No, no, LLM don't know. Okay, it is hallucinating. Uh, okay, how LLM know when to use the tools or when to use the its knowledge? Okay, so guys, see. Okay, there is we have to provide whenever you going to integrate, right? Whenever. Okay, Raja, I will come to your question. Okay, no worry. Okay, so you can see here, whenever you are providing the tools, now we have to provide some description to the tool so that LLM can understand whenever I need to utilize this different tools or where I can answer myself. Okay, so this is how you can understand. So Raja, what format LLM store this each model in the JSON, Python? What format LLM store? LLM is not store, guys. Okay, LLM response we can store in the different output. Okay, we can store in the JSON format. We can store in the some list dictionary. Okay, we can store in the some list of strings. Okay, we can generally get the response as a text. Okay, but we can have this output parser, different output parsers to store this LLM response in the different format. Okay, by default we are not going to store this LLM in the different format. Okay, so we are what will do? So LLM we are going to call this LLM with the help of API call, and then we are going to what is the response we are getting. There is output parser. With the help of output parser, we are going to store in the JSON. We are going to store in the right the dictionary. Or we are going to store in the some of the list of strings. Okay, string format. We are going to have the different output parser to store the response from the LLM models. Okay, so that is the things. Okay, so we'll proceed further, guys. So now we can see we understood, right? There are the different stores, guys. Okay, we need to provide, right? This LLM don't have the HR policy document, right? So what? Just 1 second. Okay, so we are providing this. Okay, we are providing some data. Okay, we are providing some store, and what are the different way to provide this knowledge? Okay, so there are the different way. Let's suppose the data is the structured data, right? So there are the multiple ways, guys. Okay, we can store this knowledge. You can say structured data or unstructured data is there. Let's suppose some PDF are data, PDF are there. So we are going to store as a unstructured data, and there is sometimes we have the structured data, right? So we have the unstructured data and structured data. Okay, structured data. So you can see here, let's suppose this LLM, right? LLM have this, right? LLM, this HR policy documents. Okay. So this is the, we have the PDFs, different PDFs are there, guys. Okay. And these PDFs are nothing but the unstructured data. We can generally call it the unstructured data to this PDF. Okay. So now we are going to unstructured data like PDF. Okay. You can mention like this. We have this PDF. We have the docs. We have this PPT. Okay. We have the markdown files. Okay, then we have this HTML, right? HTML, JSON, right? Semi-structure, we can say JSON. Okay, we have the different types of unstructured data is there, and some structured data is there, right? You can see, let's suppose structured data is nothing but the CSV file is there, some Excel file is there, right? Or you can say some big data, we have the Parquet file also, right? So Parquet file also there. Okay, structured data we can generally store in this, right? And structured database like MySQL database, right? MySQL database we can store. Then we can store in the Postgre, Oracle, right? Postgre, SQL. Okay. Then we can store in the Oracle. We have the different database. Okay. We know you guys pretty much aware of this, right? Different databases. The structured data is there. CSV file, Excel file, Parquet file. We can generally store in the database. But as of now, we are discussing our concentration on the HR policy documents is there. Let's suppose, and this is the unstructured data, right? PDF data, right? So we are going to store in the, what is the best way to store this PDF unstructured data? You can see here. The best way to store this unstructured. Okay. To store this unstructured data in the vector store, guys. Okay, there is a vector store will be there. Vector store will be there. In the vector store, there are the multiple types. Okay, in the vector store, there are the multiple. Okay, in the vector store, we can store in the in memory. Okay, we can store the vector store in the memory, or you can say we can store in the some cloud data also, right? In the cloud also, right? In the in memory, we have the different types. What are those different types? Okay, so we can in the in memory. So we have the database like vector store like a in memory one type is there, or we can say files is there from the Facebook, guys. Okay, from the Facebook. Okay, they come up with this vector store as a files in memory database vector store, and there is a Chroma. Okay, Chroma DB, guys. Okay, there is another database, the Chroma DB. Okay, Chroma DB is there. Okay, so this is the in-memory database, files, vector store, and Chroma DB. In the cloud, guys. Okay, in the cloud we have the different databases. Okay, in the cloud we have the different database. Let's suppose the Pinecone is there. Okay, Pinecone is there. Then we have this in the Azure cloud. Okay, in the Azure cloud we have this. Okay, in the Azure cloud we have this Azure Cosmos DB is there. Azure Cosmos DB there, or you can say Azure search is there. Okay, Azure AI search is there, which is helpful for the storing the vector store. Okay, and then in the AWS, guys. Okay, in the AWS the recent new, right, S3 vectors, right? X3 vectors are there. S3 bucket, you know, guys, right? But S3 bucket and S3 vectors, they come up with this. Initially, they have this open search as a vector store, but now they come up with that one extension. AWS S3 vectors are there. And then Postgres, right? Postgres database, this structured database, right? This is the Postgres also structured database, but then now they have provided one extension for this PG vector, right? For the store the, right? We can see the PG vector is there. Okay, from this PostgreSQL, right? PG vector from the PostgreSQL. Okay, PostgreSQL, we have the 3G vectors is there. Okay, and then AstaDB. Okay, there are the Malware. Okay, there are the multiple DB guys. Okay, in the cloud, we have the different databases. Okay, we can store, and in memory, we are going to store in the FIS and ChromaDB. And there is also one is the in memory also, in memory, right? So we have the three types: in memory, FIS, ChromaDB. In memory, in the cloud, we have the Pinecone. Okay, Azure cloud, we have the Azure Cosmos DB, Azure AI Search, AWS S3 vectors are there, PG vector, Postgres servers, right? So these are the different vector store we are going to store the data. But now you can see, guys, okay, so now we are going to understand this RAG architecture, right? So now you can see what is the things, right? Whenever we are going to provide, right? Whenever the user is asking this query to the LLM, LLM don't have the knowledge about this HR policy, company HR policy document. So LLM will give the response. It has the capability to generate the next word. So this response is getting some incorrect response, and that is called, we can call it hallucination problem, right? So response, we are getting this incorrect response or incorrect answer with competence, and that is the hallucination problem. Okay, LLM don't know, but LLM has the capability to predict this next one. Okay, based upon this input. Okay, but now what we did, we decided we can provide this, right? We decided to provide this context. Okay, we decided to provide the context, and those context can be any, we can, with the help of tools, with the any web search is there, or let's suppose some documents, right? Some policy documents where we are going to provide with the help of some store, right? Store means we are providing some memory, right? It can be, it's a depend upon which data. Unstructured data is there or structured data is there. Okay, in the unstructured data, we are going to utilize this PDF, docs, PPT. Okay, these are the different database we have. And the best way to store this unstructured data is the vector store. In the vector store, we are going to store in the in-memory is FIS, ChromaDB. Okay, in memory, these are the different in-memory vector stores are there. In the cloud, we have the Pinecone, Azure, AWS, and this is the PostgreSQL, right? The PG vectors. There are AstaDB is also there. Okay, there are the multiple databases. Okay, you can, I will give the documentation link also. You can just read about it. AstaDB, then Malware is there. Okay, there are the multiple databases. Okay, so now what we'll do, so we are going to understand. Okay, so let's suppose we are providing some context, right, with the help of some databases. Okay, let's suppose. Okay, let me take your doubt if any. Uh, okay, can you give them dynamic data like Confluence link? Okay, instead of the static ones. Yes, yes, definitely you can give this. Okay, Harish, you can definitely you can give the this link also, right? But there is a, what is the disadvantage? I'm going to explain now. Okay, if you provide the whole data, no? So what is the different advantage? Let's understand it. Okay, if you go provide the direct data. Okay, so now we can see. So let's suppose. Okay, so we are providing. Okay, so what we did, what we understood so far, we have to provide this data. Okay, so let's suppose we are asking this query. Okay, this is the user query. Okay, this is the user query, and we are this query, right? We are passing this query to the LLM model, right? So we are passing this query to the LLM models, right? We are passing this user query to the LLM models. Okay, so right, and we are getting the expecting some response. Okay, we are getting some response here. But here, not only user query, guys. Okay, we are passing some context. How do I pass the context? Okay, I need to pass some context. Okay, so here we have the different documents, right? Let's suppose we have the different documents here. Let me rewrite this. Just I will rewrite. Okay, so you can see we have the documents. Let's suppose this is the HR policy documents are there. HR policy documents are there. Okay, and this content of this document element don't have, because element is not trained on the my private organization data, right? So that is the reason element not able to answer. But what we decided, so we have the different PDFs. Let's suppose we have the different PDFs here. Okay, different, it can be, right, docs, it can be text, or it can be different formats. Okay, let's suppose we have the PDFs are there. Okay, just 1 second. Okay, all right. So we have the different, let's suppose PDFs are there, or let's suppose we have the docs file also there. Some other files are docs file, some other text file, some other PPT, right? There are multiple data files will be there. So what we'll do, so we have the different data we are going to load with the help of some different document loader. Okay, we are going to, with the help of some document loader, we are going to load it, and then we are going to store in the some database. Let's suppose we are going to use the some document loader. Okay, document. loader will be required, guys. Okay, so this is the as per the different document. Let's suppose there is a PDF document is there, so we require PDF loader. There is a docs document is there. There is a docs. There is a text document. There is a text loader will be there, right? Some web data will be there. So we are giving the web-based loader also there, right? So we have the different data as per the different documents. Okay, for the different documents we require the different document loader. I will explain what are the different document later part. But understand we are having the different documents and we are with the help of loading with the help of document loader. So what it will do, it will going to read this content. Okay, it will going to read this content with the help of document loader, and then we are going to store in the some of the database. Let's suppose there is one database. Okay, so this is the database. Okay, so this is the one database we have. Okay, so what we did, okay, it can be in memory or it can be any database, guys. Okay, it can be in memory or you can say it can be cloud based. Okay, any database we can going to store. As of now we are not decided we are going for this SQL database or vector database. Okay, structured database or vector database, we are not decided. Just what we did, so we have loaded this document. Okay, with the help of different document loader. Okay, we are going to load this document, and then we are going to load this document here, and we are going to store this document. Okay, so you can see here I'm going to store this document content here. Okay, I'm going to store the document content. Let me rewrite this. With the help of this, we are going to load this document content. Okay, all right. So we have loaded this document with the help of document loader, and we have stored it in this database. Okay, so let's suppose we have the different PDFs are there. Okay, multiple PDFs are there, right? Tens, hundreds, thousands of PDFs will be there in the organization. We are going to load. We are going to load this with the help of document loader, and we are going to store in the database. Okay, but let's suppose now what I'll do, I'm going to ask this question. Okay, let's suppose user is asking this query. Okay, the user is asking this query. This is the user query. Okay, we are asking this user query. Okay, this is we can call as the query. Okay, now what we'll do, so we are going to hit this query. Okay, so we are going to according to our query, guys. Okay, let's suppose this is the user query, and this user query will pass to this knowledge base. Okay, we are passing to the database. Okay, let's suppose the user is asking some of the questions from this PDF. Okay, PDF data. Okay, user is asking the question from the PDF data, and let's suppose there are the hundreds of pages in the PDF page. Okay, there are the hundreds of PDFs in the pages. Okay, this is the one. There is a multiple PDFs. Okay, there are the multiple PDFs. But let's suppose we are asking some the leave policy. Okay, so we are asking about the leave policy. There is one document about the leave policy is there, or promotion. Okay, later is there. Okay, there are some HR policy related documents are there in the industry, right? So we are asking some of the, let's suppose, leave policy. Okay, user is question asking about some leave policy. The user is question related to one of the particular documents. Okay, there are the different thousands of PDFs. Let's suppose we have the hundreds of PDFs. Okay, in the hundreds of PDFs, there is one PDF is related to this leave policy document. Okay, this leave policy document. Okay, now what will do, so user is asking this query. We are going to search. Okay, we are going to search on the whole database. Okay, because we don't know where this data is the content stored with respect to the user query. We are going to search on the whole data. Okay, we are going to search on the whole data. Okay, so we are going to search this user query. It is going to search on this data. Okay, it is going to search on this data. It is going to search on this data. So let's suppose, right? So we got the one of the PDF here. Okay, let's suppose we got the one of the PDF, which is having this relevancy, some relevance. Okay, with respect to the user query, and this PDF is there. Leave policy PDF is there. Okay, so what will happen? So we got this context. Okay, we got this context here. So this context here. Okay, suppose we got this matching PDF, matching content from this PDF, and we are going to get this context here. Okay, so we are getting this context here as a whole PDF. Okay, as of now we can understand, guys. Okay, so what we did, okay, so we have this user query. Okay, we have the user query. User query will be, it will going to search here. Okay, it will going to search on the every PDF. Okay, it will going to search on the every PDF. Let's say first PDF, second PDF, third PDFs, the text document, docs documents are there. Okay, there are the multiple documents, thousands of documents. It will going to search. Okay, and according to, let's suppose, as per the user query, it got some response. Okay, it got some relevant response. Let's suppose PDF 1. Okay, PDF1, it got the one response from the PDF1. The PDF1 is related to, let's suppose, leave policy. And the leave policy, there are lots of pages. Let's suppose 100 pages is there. Okay, let's suppose there is 100 pages are there. Okay, so what we did, so initially we have just we have asked the question, we search on the different page content, and we got this one page content where having this, there is the hundreds of pages in this PDF. Okay, so we got the context here. Okay, we got the context here as like this. So now we can see I'm going to combine this. Okay, so we are going to combine this context and the query. Okay, and we are passing to the LLM model, right? We are passing to the LLM models. Okay, what do these LLM models will do? Okay, it will going to, based upon the similarity search, we'll get the context, and then we are passing to the LLM model. Now we can see we are passing to the LLM model. Okay, and this LLM model will generate the response. Okay, LLM model will generate some response here. Okay, this response will be, some response will be processed here, guys. Okay, but now you can see, okay, there is some limitation here, guys. Okay, this LLM model able to solve this hallucination problem. Because why? Because we are asking this user query. Okay, initially this LLM, right? Initially this LLM model don't have the context, right? Initially this LLM model don't have any context related to this HR policy document. So it will give some incorrect response with confidence. That is hallucination problem. Then we have decided to provide some context. Okay, we have decided to provide some context to the LLM model so that LLM can generate this response and solve the hallucination problem. So we have come up with this solution. What we did come up with solution, we have the different policy documents are there. We are loaded with the help of different document loader. We are going to store in the database. Okay, and in the database, what we did, we are applied the some similarity search. Okay, let's suppose in the similarity search. Okay, if the relevant user query is there, okay, or user is asking what is the review policy about this organization. Okay, so it is it is search on the different PDFs, different PDF documents. It will got one PDF document as a context. Okay, you can see this is the PDF document as a one context. In this context, we got, let's suppose, hundreds of pages. Okay, let's suppose we got the hundreds of pages, and we are going to pass this context as a PDF. Okay, so we are going to combine this query, the context, and we are passing the LLM. But there is a limitation of LLM. What is the limitation LLM? There is a context window. Okay, there is one limitation of this LLM having the context window limitation. Okay, context window means, what is this context window? Means how many tokens, this LLM can process. Okay, how many tokens, how many input token, right? LLM can process. Okay, it can process or it can see. Okay, at one time. Okay, that is called context window. Okay, different LLM have the different context window. Okay, in the whenever this, right, LLM start in the 2022. Okay, whenever you have the 22 year 22, the LLM was very much less context window, guys. Okay, LLM has the very much less context window. Sorry, not 22. Okay, it is the 22. Okay, 22. This LLM, right? Different LLMs come up with some the context window. Okay, initially they have the 16K thousand token only they can process. Then later part, right? They have increased this limit to the 30K thousand token, then 64,000 K tokens, then 128K tokens. Now they increase this limit. Okay, to now they, some of the LLMs can process this 1 millions, right? 1 million tokens also, right? 1 million token. But this is now in the 2025, right? 2024, 25. But in 2023, 24, there are some limitation, guys. Okay, whenever when you're in the start of this, right, the LLM field, right, generative, we have started, right, the LLM model have this some limitation of the context window. Means it can only see, we can only able to process this 16,000 tokens or 32,000 of tokens. Okay, so there is a limitation. But here what we do, so we are providing the whole PDF content as 100 pages. Okay, and let's suppose this pages content is less than, okay, if the page content is the less than equal to context window, okay, less than equal to context window, then you can process this, LLM can process this, process this pages content, and it will give the response. Okay, but if you see the this context, what is the context we are received from this, right? What is the context we have received from this database? Okay, in the memory, okay, or databases, and this context is a greater than, okay, if the context is a greater than this context window, okay, if the context is a greater than this context window, then LLM cannot process this response. Okay, LLM cannot respond because this context window, LLM has limitation to process this input. Okay, 11 has the limitation to process this input. So if the input is within less than equal to this context window, then you can process this. Otherwise, it will not going to process. There is a problem. This is the problem. Then we have to handle this problem. Okay, so how do we handle this problem? Okay, so we have to handle this problem. We are going to come up with some chunking strategy. Okay, so we come up with this chunking strategy to solve this problem. Okay, so this is the context window problem. To solve this context window problem, okay, so we have to come up with this to solve this. So we have come up with this chunking strategy. Okay, we are going to chunk this document. Okay, we are going to chunk, or we can say chunking strategy. Different chunking strategy come into place. As of now, initially what we did, we have loaded document, we have stored this as it is, guys. Okay, but now we come to know that there is some problem. Okay, if the context is less than this context window, then it will able to process this. LLM able to process and generate the response. But if the context greater than this, right, greater than this context window, LLM not able to process this input. There is a problem. So this problem we have to solve with the help of some chunk in the document. Okay, so what we'll do? So we have the document. Okay, so we have the, you see the documents are there. Okay, so let's suppose HR policy document is there. Policy document is there. HR policy documents is there, and the HR policy document, let's suppose there are the different documents are there, guys. Okay, these are the having, let's suppose PDFs are there, the text files are there, docs files are there. There are multiple documents are there. What we did, we have decided to, first of all, we are going to load this document, right? So we are going to load this document, and then we are going to chunk it. Okay, so we are going to load this document, and then we are going to, okay, so you can see we are going to load, and then we are going to chunk it. Okay, so we are going to make the chunk like this. Okay, I will not, okay, I will not discuss about this as of now. Okay, what is the chunk size and what is this, all this. Okay, later part I will discuss. But what we decided, we have the PDF document. So we are going to split this. Okay, so we have decided to split this, okay, into chunks. Why we are going to chunking for? Because there is a one problem, there are the two problems, guys. Okay, first is there is a conditional limitation, and if you search on, right, if you search on the whole document, and this process will be very slower. Okay, another problem is there. Okay, if you search on the whole document, right, this process will not faster, this process will be very slow. Okay, if you search on the whole document, now it will process will be very slower process. Okay, because if you are searching on the whole document, but now what you decided to solve this problem, so we have decided to come up with some chunking, splitting. So what is the benefit of chunking or splitting? So handle this problem of context window, handle the problem of context window. This is the main problem. Okay, and then another problem is to make a faster retrieval. Okay, so make a some fast, okay, fast searching, or you can say is to optimize this search. Okay, so we are going to make some faster search. Okay, so let me remove this part. Okay, as of now, just to focus on this context window. Okay, now we can say, once this splitted document, we are going to store in the database again. Okay, again we are going to store in the database. Okay, one we are going to store in the database. It can be any database, guys. Okay, in memory or cloud. Okay, blob storage, S3 bucket. It can be any, right? It can be any database. Okay, as of now, we are going to chunk it, and then we are going to store this. And in the storing, guys, what we'll do? So we are going to create this ID, right? This is the ID one, and this is the chunk. Okay, it is the chunk. We are going to call it the chunk. Okay, so this is the C1 chunk. This is the C2 chunk. Or let me simplify this further. I'm going to mark as a C1. Okay, the chunk one. This is the ID2. This is the chunk 2. Let's suppose this is the ID3, and this is the chunk 3. Okay, so now the user will ask this question again. Okay, so let's suppose user is asking this question again. Okay, user query will be passed, right? User query passed through this, and this is the user query, you can say. Okay, this user query, what will do? So user will hit this knowledge base database. Okay, and then we are going to search on the each of the chunk, right? It will going to search on this chunk. It will going to search on this chunk, and it will going to search on this chunk on the basis upon this similarity search, we can say, right? It is going to search on the text data, guys. Okay, as of now, this chunk is a text data, right? This is text chunks only. It will going to search, and based upon, let's suppose it got this chunks. Let's suppose it got this chunk as a this chunk 2 and chunk 3 is a similar. Let's suppose it got the chunk 2 and chunk 3 are similar. we are fetching as the context. Okay, we are going to fetching as the context. Okay, as a chunk 2 and chunk 3. Okay, so now we are going to add this, right? So we are going to add this query plus prompt as a query plus context as a one prompt, guys. Okay, so we are going to bind this together, okay, as a prompt here, and then we are going to pass. Now we are going to pass to the LLM model. Okay, LLM models. Now LLM model will process this input and it will give you some response here. Okay, it will go into process and it will give you the response. Okay, but now you can see, okay, this is LLM model we are able to, right? So we have to make the chunk. Okay, this chunk size should be less than the context window. Let's suppose we know, right, which LLM model we are going to know. We know. Let's suppose I'm going to utilize this GPT series model. I know what is this context window of this LLM model. Okay, let's suppose I'm utilizing the Gemini model. So what is the, okay, what is the context window of this Gemini model? Right, 2, 2 Pro, 2.5. Okay, let's suppose we are using the Llama model. Okay, so we are using the Llama model. So we are utilizing different LLM models. We know the context size. Okay, all this LLM model have the context window, right? All this LLM model has the context window. So according to that, we know, right, what is the context window. Let's suppose this Llama model having this 16K 16K is the context window. Then we have to chunk less than this chunk size should be less than 16K so that LLM can process this easily, right? And it will generate the response. We are getting the response, and this is how we are able to process this input, and we are getting the output. This is how we are getting. But now there is one problem here. Okay, what is the problem here? You can see here we are searching on the similarity search, right? Here we are searching on the similarity search. Okay, with respect to user query, but there is a problem. What is the problem here? If you closely observe, guys, okay, we are searching on the text, right? So we are searching on the text chunk. Okay, we are searching on the text data, and this text data is not efficient, right? If you see here, we are, this is the chunks are there, right? This is the text chunks are there. Okay, text chunks are there. Okay, text chunks are there. And whenever you are searching, right, if you are searching on this text data, right, whenever you are searching on the text data, okay, we are searching on the text data, this is not a faster, okay, this is not a optimal search. Okay, it is not a faster, or you can mention it is a not a optimal. Okay, it is a not a optimal search. Okay, it is not optimal because searching on the text is a takes the time consuming process. Okay, it is a time consuming process, you can mention. Okay, it is a time consuming process, it is a taking the time to search on this. Okay, so then what we have to do, so we have to solve this problem. Okay, so now initially we, by chunking, we solve the context window problem. Okay, but there is some another problem. Now we come, right, so we have this problem as the searching on the text. It is a taking the time consuming approach. Okay, so what we have to do, so what is the best approach here, guys? Can anyone tell me? Instead of searching on the text, what we can do? Yes, we have to search on the vectors. Okay, so we are going to create on this, we are going to create the vectors, and searching on the vectors is very faster. Okay, searching on the vector is very faster. Okay, very fast approach. Okay, and you can say it is a faster, or you can say efficient, or you can say optimal. Okay, you can say it is the optimal way to search on the text. Instead of search on the text, we can use the vectors. Okay, so we have decided to solve this problem. Now we are getting this, guys. Okay, it is a taking time to search on the text, not an issue, but it is the right. So it was come up with the best solution, right? Best approach. Okay, what is the best approach? We are going to store this instead of chunk. We are going to store it the vectors of these chunks. Okay, and then we are going to search on the vectors. It will going to make a faster, make a efficient search. Okay, that is the reason we go for the vector search. Now you can see, okay, so now we can see here is the way of the documents. Okay, this is the HR policy documents are there. Okay, HR policy documents are here, right? So we have loaded this document, and we are going to chunk this document, right? So we are using the splitting the documents with the help of chunking. I will explain this different chunking strategy later part, but now we are utilize this chunking. So we have decided to split this document to handle this context window problem. Okay, we have split this document like this. Okay, we have split this document in the small chunk size. Okay, then after this chunking, guys, okay, so we need to create the vectors, right? How to create the vectors, right? So we have to create this vectors. Okay, so we require some embedding models, right? We require some embedding models. Okay, we require some embedding models to create these vectors. Okay, there are the different embedding model. I'm going to explain this later part. But as of now, there is a embedding models which will what will do. So it will going to create this one vectors for this. Let's suppose this is the one chunk. Okay, I have pickup and it will going to create the one vector. Let's suppose 0.1. Okay, this is the chunk. Let's suppose we have the one paragraph is there, right? So this is the text is there like this. Okay, we have the different text here, right? In the each of the chunk, one paragraph is there, or let's suppose one page is there, or group of sentences are there, right? Like this, we have the chunk, right? But now what we did, so we have pick up this one chunk and we are going to convert in the vector form. Let's suppose 0.1, 0.2, 0.3. Okay, another chunk we have pick up, and let's suppose we are calling it the 0.4, 0.5, 0.6. And let's suppose another chunks we have pick up, and this is the vector is a 0.7, 0.8, and 0.9. Okay, this is for explanation purpose. I have taken the vectors like this. Okay, this is the some vectors. Okay, just the three-dimensional vector I have taken. But in the later part, I will explain what is the dimension of this different embedding model. What are the different embedding model? I will explain later part. But just concentrate here. Okay, so we have the documents. So we have loaded this document. We have split it, and then we have created the embeddings. Okay, so now guys, as of now, right, we are storing in this data, right? If you see here, we are storing in the any database, right? We are storing in the any database, that is fine as of now because we have the text data. You can store in the blob storage, we can store in the S3 bucket, we can store in the drive, OneDrive, anything locally also, that is fine. Okay, but now you can see we are creating the vectors. Okay, and then vectors will be stored in the vector databases, right? So I'm going to store in the vector databases. Now you can see this database we require as a vector database here. Okay, so we require the database as a vector store because we are creating the vectors, and this database now is the we require the vector database. Okay, vector database. Okay, vector database. Now you can see here in the vector database, what I'll do, I'm going to create this ID. Okay, this is the ID, this is the chunk, and it's the vectors. Okay, this is the vectors. Let's suppose this is the chunk one. Okay, this is the ID one. This is the chunk. Okay, in the chunk one, we are going to store as it is this chunk. Okay, some chunks will be there, and then we are going to store this ID. Okay, vectors. Let's suppose we have the vectors of 0.1, 0.2, and 0.3. Okay, we are going to store like this. Okay, then ID2. Okay, second chunk. Okay, second chunk will be there. So we are having this ID2, and this, what is the chunk? We are going to write this chunk as it is. Okay, the second chunk. Let's suppose we have this chunk like this. Some text will be there, and corresponding this vector will be there, right? Corresponding vector. Let's suppose 0.4, 0.5. Okay, let me write this in the bigger picture so that it will be easier. Okay, so now you can see we have this ID. Okay, so we have this ID, then we have the chunk, and then we have this vectors also there, right? Vectors. Okay, so ID is 1. Okay, we are going to chunk as a we can call as the chunk 1, we can call as the chunk 1, and this is the vector 1, right? Vector 1 is nothing but let's suppose 0.1, 0.2, and 0.3. We have stored this vector. Okay, second ID, this chunk 2 will be there. This is the chunk 2, right? This is the C1, this is the C2, this is the C3. There are multiple chunks size. Okay, but as of now, I'm making simplified by taking the only 3 chunks. Okay, and let's suppose this is the second chunk, 0.4, 0.5, and 0.6. We have this, it's vectors. And this is the ID 3. So we have the chunk 3. This is the, let's suppose 0.7, 0.8, and 0.9. Okay, so these are the different vectors. Okay, so now what I'll do, I'm going to, because this is the vectors are there, right? So we have to store in the vectors in the some vector database, right? So we are going to create some vector database, and we are going to store in the vector database. Okay, this information. So I'm going to call as the vector database. In the vector database, we have the ID, chunk, and its vectors is there. Let's suppose now user is asking this query, guys. Okay, user is asking this query. Okay, user is asking this query. Okay, so what we'll do? So now we have to search on this vectors, right? We are not searching on the directly text chunk. Okay, we are not searching on these chunks. Okay, we are not searching on the text. What we'll do? We have to search on the vectors. Okay, then what I'll do? I need to create this embeddings of this also, right? This is the user query will be there. We cannot directly user query in the text format, right? We have to pass in the natural language like a text, but this user query we have to convert in the embeddings also, right? So what I'll do? I'm going to create this embeddings of user. Let's suppose we got this embedding as a 0.5, and let's suppose 0.65, and let's suppose 0.75. Okay, we got this embeddings of this. Okay, we got this embeddings like this for the user query also, right? So user query, this was the user query, and we created this embeddings of this user query, right? The embeddings of user query. We are going to create this embeddings of the user query. And now what we'll do, so this user query will be embeddings will be there, like this is the embedding. Will hit on the knowledge base. Okay, it will hit on this knowledge base. Okay, and here let's suppose it is search on the each of these vectors. Okay, it will going to search on these vectors. Okay, it will search on these vectors. It will going to search on this vector. It will going to search on these vectors. Okay, it will search, right? You can see we got this vector, right? You can see here, observe this closely. So we have this vector is the, let's suppose 0.55, 0.65, and 0.75. So these are the two vectors. Okay, if you see here, these are the closed vectors. Are these are the, this is the one vector is closed, and this is another vector is close to this user query, right? So what we'll do, so we are going to pick up these two chunks. Okay, chunk 2 and chunk 3, because this is the user, right? This is the user query having this vector 0.55, 0.65, and 0.75. And if you search based upon the similarity search, there is a different types of search will be there, guys. Okay, I'm going to explain later part, but you can see as of now we are just utilizing this. Okay, so we have this 0.55, 0.65, and 0.75. It will going to search on this vector. Then again it will go into 0. The same query 0.65. We just say it's query represent the vector form, guys. Okay, we are searching on this vector, and likewise this same query having this embedded form 0.65, 0.75. It will go to search on this different vectors. But if you see here, these are the two vectors are close to this way, this query, right? We are utilizing the some similarity search. Okay, we are in the similarity search. Okay, we are going to utilize similarity search based upon each vector. And so now we got this vectors is similar, and this vector we got the similar. Okay, what we'll do, so corresponding, what is the chunks? The corresponding chunk, we have this is the chunk, and this is the corresponding vector, we have this chunks. Okay, so now what we'll do, so we are going to return this chunk, guys. Okay, now for the searching purpose, right? We know, right, the faster, for efficient and faster purpose, we have created this vector. So the vector job is done, guys. Okay, so it will going to help for the only for the searching purpose, fast retrieval purpose. So now we got this embeddings, and this embedding corresponding chunks. What are those? This one and this one, right? So we are getting these chunks here as a context. Okay, so you can see this is the, let me rewrite this. So this was the initial user query was there. Okay, and we are providing this context. Okay, so we are providing the context here. The context is nothing but our C2 and C3. Okay, this is the context because we got from the searching, right? By within the search, we got these two chunks as a context here. Okay, so we are going to add these two. Okay, query plus context. We generally call it the prompt, guys. Okay, we are going to bound this in the prompt. Okay, in the prompt template, this query and context. Okay, this is the query and we got the context, and then we are going to pass this prompt to the LLM model. Okay, we are going to pass this LLM model, and then we are expecting some response here. Okay, we are expecting some response, some output here. Okay, so now what we did, guys. Okay, so far, so we have the initial, right? If you see here, initially we have the problem, right? We are, what we are doing, we are directly storing the data, right? We are directly storing the data in the databases. But whenever we are passing this user query, we are searching on this whole data, right? So let's suppose the user query is a particular text, okay, particular the particular one page of this document. But what happened? We have stored, we have not chunked this document, so we are getting the whole document as a context here. And whenever passing the whole document to the user query to the LLM, there was some limitation. LLM cannot process this beyond its context window. Okay, so this is how the limitation we have. If the context less than the, right, this context less than this context window size of the LLM, then it can process. But some of the scenario might be there, some context size will be exceeding this context window size, right? The context size is exceeding the context window size of LLM. So it will not probably solve this, right? It will not going to process, it will not going to synthesize, it will not going to response. Okay, then we have to solve this problem. So we come up with some chunky strategy. Okay, and then we come up with the, so document we have loaded with the help of different document loader. We split this document with the help of different chunky strategy. Okay, so that we are going to store as a chunk. But now you can see when the user query is coming, Okay, we are user querying, it is searching on this different chunks, but it will get in the context here. Let's suppose chunk 2, chunk 3, we got the context and we are passing to the LLM and we are getting the response here. Okay, but here this process was very slower. Why? Because we are searching on the directly on the text, and text is not optimal search, guys. Okay, text is not an optimal search. It is a time consuming for the search because this is not only three chunks, guys. In the practical, we have thousands of chunks will be there, lots of millions of chunks will be there, and we have to search on the different chunks to get the relevant chunk, particular relevant chunk to user query. So it is a time consuming process if you search on the text. So what is the approach we have to come up with? We have to come up with some vectors. Vector will be the best, right, for the faster efficient searching purpose, right? So we come up with we can go with the vector search. Okay, vector. So now initially we have the documents, we have loaded this document with a different document loader. We are going to split this document, then we are going to create the embedding of this document, and we require the vector store. Now we require the vector store. We are going to store this different chunk and its corresponding vectors. So what we did, so we have created this vector store. We have stored the chunk, its corresponding vectors also. So now whenever the user query coming, what it does, we are not directly passing this user query to search on this text data. What we do, we are going to create this embedding of this user query, and then we are passing this to the vector data source. This is the vector data source. We can call it generally as a knowledge base, guys. Okay, this is our knowledge base. Okay, knowledge base. Okay, and now we are going to search on this knowledge base. Within this is the query embeddings. It will search on these vectors. This query embedding, it will search on the another vector. This is the query embedding, it will search on the another vector, and it will find that which one is the most similar. Okay, most nearest to this query embeddings. Okay, so we got this. Let's suppose we got these two vectors. Okay, these two vectors and corresponding chunks. This is the chunk 2 and chunk 3. We got this is the most similar to this user query, and we are passing this context. Okay, we are passing this as a context C2 and C3. Okay, and now we have the user queries there, and the context will be there. So we are passing this user query and context. Now we are getting this right HR policy document, right? We initially we don't have this, right? LLM don't have the knowledge, but we are passing as the context this query as well as the relevant context from our knowledge base from the HR policy document. We are passing to the LLM. So the LLM what will do? It will going to process and it will give the correct response. Okay, so this is how we are going to solve this hallucination problem in case of this. Okay, in case of this approach, and this approach we can call it this as a, we are solving this hallucination problem. Okay, we are going to solve this hallucination problem, and this approach is called this RAG architecture case. Okay, this approach you can call as the then birth of this RAG architecture come into picture. Okay, we can say this is the call as the RAG architecture. Okay, this approach you can call as the RAG architecture. Okay, if you see here the what are the component in the RAG architecture. Okay, RAG architecture. In the RAG architecture, what is this? Why it is called the RAG architecture? Okay, you can see here there is a three terms. Okay, RAG. Okay, in the RAG, the first R is nothing for the retrieval. Okay, so let me explain this first of all. Okay, so I will explain here in the architecture itself. Okay, you can see here initially what we have the different documents. Okay, and we have the document loader different, right? So we have the different documents. Right, we have the different documents, and we have loaded this different document, and we are going to use the different chunking strategies. Okay, we are using the different chunking strategy, right? Chunking strategy. Okay, for splitting purpose, right? So we are going to utilize different chunking. I will explain this. What are the different chunking strategy? So we are going to chunk this. We are going to load and we are going to chunk this document. Okay, first of all. Okay, so we are going to first of all we are going to load and chunk this document. After chunking, what we'll do? We are going to create the embeddings of this, right? With the help of embedding models, we are going to create the vectors, right? We are going to create the vectors, corresponding vectors 0.1, 0.2, 0.3. Okay, like this, we are going to create these vectors. Okay, different chunks we are creating the corresponding. Okay, all right, we are going to create these embeddings, and then after this embedding, guys, okay, what we'll do? So we are going to store this embeddings in the vector store, right? So we are going to store in the vector store. Okay, we are going to store in the vector store. This is ID will be stored, then chunk will be stored, and the corresponding embedding will be stored, right? Corresponding embedding will be we are going to store. Okay, let's suppose there is ID1, chunk 1, and corresponding embedding will be V1. V1 is the embeddings matrix, or let's suppose I'm going to store as a directly as a okay. So okay, so I'm going to store as a this one 0 0.1, 0 0.2, 0 0.3. Okay, this is the ID 2, this is chunk 2, and then we are going to store as the embeddings of this matrix. Okay, and corresponding this ID will be there, chunk will be there, and then we are going to store as a corresponding embeddings matrix like this. Okay, so now you can see, guys. Okay, this is how we are going to create this. This is called generally indexing pipeline. Okay, this is called just generally indexing pipeline. Okay, generally we can call it the setting of the vector store. Okay, it is comes under the indexing pipeline, because we are going to create the index, right? And we are going to create the index. We are going to store this chunk and its corresponding right. This is called indexing pipeline generally. Okay, at the end of this, what is the end result of this indexing pipeline? Having this knowledge base, having this vector store. Okay, having this knowledge base or having this vector store, we can say. Okay, then we can say we can call it the knowledge base or vector store. Means all our policy document here now we store in the vector store database, guys. Okay, knowledge base and vector store. Now we can see user query is coming here, guys. Okay, so now you can see here the user query is coming from some API. Okay, this is the user is there. Okay, some application will be there, guys. Okay, let's suppose some application is there or some API layer is will be there. The user is asking to this API. Okay, user is asking some API, or you can say app. Okay, app or API to this application. Okay, user is asked the user query, right? And this user query passed, right? This user query passed to this embedding models. Okay, it will create this embeddings here. Okay, it is going to create the embedding here. Okay, let me create this embedding 0.55, 0.65. Let's suppose this is the 0.75. So now you can see, guys, we are going to create the same embedding matrix. Okay, same embedding models here. Okay, this is the call same embedding. Okay, so we're going to create this. So what is the embedding model I'm going to write? So you can see here is some embedding model will be required for the embedding purpose, right? This is the chunks. I'm going to create these chunks, this embeddings, right? I'm going to create this embeddings with the help of some embedding model. Same embedding model I'm going to utilize for this creating for this query embeddings also. Okay, so same embedding model I'm going to utilize. This is how we are going to store here, and this embeddings, right? So this embedding will hit, right? This embedding will be hit. So this we can say this is the embedding will hit the this knowledge base, and from the knowledge base we know, right, we are going to search on this different vector store, this vector embedding, and corresponding, right, we got this corresponding vectors and corresponding chunks as output. So we are going to take this as output as a context here. So we have this query. Okay, so we have the query plus the context. We have the query plus context, and this query plus context, how we are going to store, guys? We are going to store in the prompt. Okay, we are going to store as one of the prompt, and we are given the instruction here. Okay, we are going to instruction. You are the HR policy assistants. User, right, answer the user query as per the this right answer as per the receive context. Okay, so we are going to pass this prompt to the LLM model. Okay, we are going to pass to the LLM model, and then we are getting some output. Okay, so we are getting some response here, some response. So now you can see, guys. So there is a why it is called RAG architecture. Now you can see the first part is a retrieval, right? So first part is here. If we observe this, so this is I can call it the retrieval part. Okay, means whenever we are hitting this, right, whenever we are passing this user query to this knowledge base, and we are expecting some output, right? We are expecting some output, and then this is part we can call as the retrieval part. Okay, this part we are going to call as the retrieval. Okay, this part is called retrieval. And then what we'll do, so we are going to augment. Okay, so here we are going to augment this. What we are going to augment? So we are going to this query and the context. What is the context we are receiving? We are going to augment this. We are going to add, right? We are going to augment this. Okay, this is the second part. Okay, this is the first part. This is the second part is the augmentation. We are going to use the augment. Okay, augment, and then we are going to generate this response. Okay, so we are going to generate this. This is the generation part. Okay, so this is the called generation part. So that is the reason, guys. Okay, so it is called retrieval augment generation. Okay, so you can see if you combine these three parts, right, If we combine these three parts, okay, retrieval, augmentation, generation, and then it is equal to this RAG architecture is okay. It is called a RAG, retrieval augmentation generation. It is equal to RAG architecture. Okay, and this is what is the response we got. So we are going to pass this response back to this user, right? We are going to pass this response back to this user through this API or through this application, right? So we are going to build some API chatbot, API layer, or API, right? And from this, we are getting the response here to the user query. I hope now you got the clarity how this RAG architecture works. Yes. Anyone, any questions? Now you can ask your question. I will explain this furthermore, but if you have any question, now you can ask. We augment first and retrieve the next. No. We are not augmenting first, guys. Okay. What we'll do? We are going to retrieve the context and then we are going to augment it. Okay. So we can see here, if you see here clearly, observe these things. Okay, guys. This user query, right? User query will going to search on the knowledge base. It will going to search on the knowledge base vector store, and the corresponding vector. What is the based upon similar search? We got the corresponding context chunk, and we are going to retrieve this first of all. Okay, so we are going to retrieve this with respect to user query. What is the context relevant to the user query? So first is the retrieval, and then next step is the augment. Okay, this user query will be there, and then we are going to add this context, and that is called augmentation, and then we are passing to the LLM, and LLM going to generate this. Okay, and this is called retrieval, augment, and generation. Okay, the augment will not be first, retrieval will be first, then augmentation, and then generation. So I hope you got the clarity, guys, how we can implement this RAG architecture. Yes, any questions? So now we can ask your question. I will take. So if you want to train this LLM with the 30 lakhs or 3 million data sample, which LLM model will be utilized for the best choice? Okay, elastic search in the memory vector database. Okay, so now we can see, guys. Okay, so if you want to train this LLM now, 3 million data points. Okay, so we can utilize this, right? Which LLM, right? So we have to decide, right? There are the different LLM, guys. Okay, let's suppose GPT series, we have the different LLM models are there. We have this Gemini series models are there, right? Llama models are there. We have the different LLM provider, but there is some criteria, guys. Okay, if you see here, right, you can see this GPT 5 point model directly we cannot do train. Okay, why we cannot do the training of this GPT? Because they have clearly mentioned, okay, this is the closed source model, guys. Okay, this is the closed source model, and we cannot directly go for the fine tuning of this LLM model, right? So we have to instruct fine tuning. Okay, we have to provide the instruction of this LLM model, and we can fine tune. Okay, but we cannot directly go for this 5.2. They have mentioned if you want to train this model, you can train on this 4.1 and 4 models. Okay, GPT 4. Okay, this is the where it is 4 model. Yeah, this is the GPT 4.1 or GPT 4 model. You can train. You cannot directly train this GPT 5 model, 5.2 models. Okay, that is the one constraint we have. Let's suppose you are using the Llama models. Llama is the open source model. We can directly fine tune this model. Okay, but we cannot directly go full parameter fine tuning. We are going with the LoRa technique to fine tune this. Okay, so we are providing some sample data. We have some questions and answer in the format we are providing to LLM to understand. Okay, and the elastic search. Okay, elastic search is also there in the database. Okay, in the elastic search also there, the database. So please, can you share the architecture again? Okay, yes, I will show this architecture again. No worry. So just one second. I am going to explain this architecture, RAG architecture again. So if you see here, guys, okay, initially what we did, we have the documents are there. Okay, different PDF documents are there. And then we are going to load with the help of different document loader. I will explain now what are the different document loader, different chunking strategy. Okay, so we have the different document loaders are there. We are going to chunk this document loader. We are going to chunk it, and then we are going to store in the vector database. Okay, so we are going to, this is the different document loader. We are going to load with the help of different document loader. We are going to chunk it in the different small function, and then we are going to store in the vector database. And then we are going to, we are going to create these vectors, okay, with the help of different embedding models. And then we are going to create the vector store. In the vector store, we have the different IDs, different chunk, corresponding chunks, and corresponding embeddings we are going to store. Now user query is there, right? User query will be there from the application and UI API. So we are, first of all, we are going to create this user embeddings, user query embeddings, and then we are going to hit this to the knowledge base or vector store, and we are getting the based upon the similarity search here. I will mention here. Okay, there is a different types of similarity search here, guys. Okay, MMR will be there. Okay, the similarity search. Okay, or you can use the MMR, maximum marginal relevance also. Okay, but as of now we are going to utilize the similarity search. It will going to based upon the similar vector. It will going to find which vector is similar. So we got the two vector similars, this chunk 2 and corresponding vector. What are the corresponding vectors? What are the chunks? This one is the chunk. Corresponding vector. This is the chunks. Okay, we got the two chunks. So we are going to add this context as a chunk 1 and plus chunk 2. Okay, so we are going to add this chunk and chunk 2. Okay, so we are going to add as a, okay, let me, the chunk 1 plus chunk 2. Okay, because we are getting the context for the user query. Then we are going to first of all retrieve this. Okay, from the knowledge base we have to retrieve. Now this is the user query, we have to retrieve the context from this knowledge base, and then we are going to augment this. Okay, we are going to augment means we are going to, this is the user query will be there. Okay, and then we are having the context, we are going to augment this, and then as a prompt, okay, in the prompt we are going to augment it, and then we are passing to the LLM will generate the response. This is called generation. Okay, so this is the three terms: retrieval, augment, generation, and equal to RAG architecture, and it will gain the response of the user, right? So the API and user API. I hope you got the clarity, guys. Yes, any questions now? No questions? Okay, I will explain now what are the different document models are there, different chunking strategy are there. Okay, so any question, guys, on this part? Okay, I hope it's pretty much clear, guys. Okay, great. So yes, you can ask your question. Yes, yes, let me see. Yes, Nilesh, you can ask your question.
Hello.
Yes, yes.
First of all, thank you so much. It's a good. So my question is that, for vector database, so our
Mm-hmm.
application is deployed in a local system, okay,
Mm-hmm.
and we use a Elasticsearch for vector DB. But point is that, suppose first of all we embedding the data in our office data center, and then we can uh, create the tar file for vector database, and tar file store in a hard disk, and the hard disk will be the uh, like another data center, and then another data center one another engineer will push and get the database. But my question is that, is there any mechanism to migrate the vector database from one server to another server? And second point is, how we can backup policy we can allow for vector database, like our vector embedding is running, okay, and if I incremental snapshot for server, okay, so sometime I got the issues like vector index is corrupt.
Okay.
So okay, so that's a main point for
Okay.
vector database backup policy, and how we can achieve highly available vector database, how we can manage read and write requests for vector database, and how we can migrate the vector database from one server to another server in a local environment. For security reason, our companies like working on local systems for like legal AI projects. So for they are not allowed to use a pine code and S3 bucket, S3 vectors, and AWS open search. So
Okay.
in a physical way, I think, could you please help us and like understanding how we can achieve this? Thank you.
Okay. Okay. Yeah, yeah. So yeah, it is your personal question, right? Okay, no worries. Okay, I will take your question. Okay, offline. Okay, no worries. Okay, but you can see If you have any doubt now related to this RAG architecture, you can ask it. Okay, I will give the general answer to this question. Okay, but you can connect with me over this, right? The calls or the chat. Okay, I will give this detailed answer. How can map this actually, guys? We have to mapping is will required. Okay, whenever you have to migrate this some database now, vector database, we have to some kind of mapping will be there because in the vector database we have the dimensions. I need to see here the dimension of the database first of all, the what is the dimension we are stored in the which database we are utilizing, what is the dimension of that. Accordingly I need to check, okay, what is the any documentation for that particular migration purpose. So there is some mapping kind of mechanism will be required to transfer migrate this one database to another, because we have the data we are storing in the particular dimension, guys. Okay, so each with embedding different embedded models have the different embed these dimensions. Okay, some database might have the 568 dimension, some have the 1000, right, 56 dimension, some have the 1456 38, like this different dimension will be there. If you are moving this dimension into the some lesser dimension, there will some loss of information will be there. Okay, so we have to create some mapping so that particular dimension will be carrying. Okay, let's suppose we are moving from this local to, let's suppose, on another platform. Okay, so in that case, so we have to create some mapping in between so that I will be able to store this complete without any loss of information. Okay, so for more information, we'll connect and discuss. Okay, I will provide some documentation link also for you guys. Okay, so you can refer this and you can apply this also. Okay, so there are the multiple documentation, okay, around it, how can start the mapping and start the migration of the database also. Okay.
Okay, okay. Thank you, thank you.
Okay, okay, great. So now guys see, okay, I will discuss if any other question is, I can see the hand is raised. Okay. Uh, okay, all right. So I have answered this your question. Okay, now you can see, guys. Okay, what we'll do. So now we are going to understand what are the different document loaders are there, what are the different chunky strategies are there. Okay, so we understood RAG architecture. If you have any question, you can ask these questions on this RAG. Okay, but now we are going to understand what are the different document loader are there. Okay, there are the different components. Okay, RAG architecture components. Okay, RAG architecture components are there. Okay, first we will require some document loader. Okay, first component is nothing but the document loaders are there. Okay, it's a depend, guys. Okay, which document we have? Let's suppose we have the different documents. Okay, we have the different documents here. But which loaders, which document loader we are going to utilize? Okay, let's suppose we have the PDF documents is there. Okay, then we are utilizing the different PDF loaders. Okay, let's suppose I'm going to say the PDF document is there. In the PDF document, we have the multiple loaders, guys. Okay, the Py PDF is there. Okay, the PyMu PDF is there. Mu PDF. The PDF plumber is there. PDF plumber is there. Then PDF miner is there. Okay, PDF miner is there. Okay, so we have the different document loader, guys. Okay, so accordingly, let's suppose this is the simple text data, we can generally go with the PDF, but the text with the table data, no? So generally this different document loader will work. This PyMu PDF is work better. Okay, there is a recently they come up with some document loader, PyMu PDF for LLM. Okay, PyMu PDF for LLM. Okay, PyMu PDF for LLM. So this is the different document loader: PyPDF, PyMu PDF, PDF Plumber, PDF for the only for PDF, guys. Okay. So let's suppose there is a compliance page are there. We can load the compliance page. Compliance page loader will be there. Okay. Let's suppose we have the text data. Okay. So let's suppose we have the text data. So we have this text loader is there for the text data. Okay. And then we have this some of the files are the web, right? So we are accessing from the web. Some of the files are there from the web. We are directly access some of the blogs, some of the web files, right? We have the web-based loader also there. Web-based. Okay, web-based loader. Then let's suppose we have the JSON file is there. So we have the JSON loader is also there. Okay, JSON. Okay, JSON loader. Let's suppose we have the docs files are there. Where is the docs loader will be there. Then we have this. Sometimes there is a directly, guys. Okay, so we have the CSV file. You can use the CSV loader from the LangChain. Okay, these are the. If these loaders are not available, then we have to write the custom code. Okay, but this different loaders are provided from the LangChain. Okay, for this Okay, to implement these applications, so we require some framework, and this framework is nothing but the LangChain, LangGraph are the framework, guys. Llama Index, LangChain, Llama, right? These are the different frameworks we have to integrate this LLM into the application. We can interact with this LLM, right? Application, LLM based application, we can with the help of LangChain framework. LangChain is providing these different document loaders. Okay, we have the different document loaders. And as per the document, there are multiple document loaders. I just listed out the some of the document loaders. There is unstructured loader is also there. Okay, whenever the data, the text data, guys. Okay, whenever the text data and this image data. Let's suppose we have the table data, or sometimes we have the image data also there, right? So we have the this is the most preferred, this unstructured document loader. Okay, most preferred. Along with the then we have to understand which loader we data is we are going to access. Accordingly, we have to choose the different loaders. Okay, then we have this different chunking strategy. Okay, second part is the chunking strategy. Okay, chunking strategy. Okay, in the chunking strategy, what are the different chunking strategy we have? So we have this, right? Let's suppose we have whole document we are going to split as one chunk. Then we have the document based chunking is there. Okay, document based chunking is there. Okay, or you can say the text splitter is there. Okay, we are going to use the text splitter. Okay, character splitter. It will going to split this. I will showcase this. Okay, I will showcase the documentation of this. Text splitter, character splitter. Then is the recursive is very famous. Okay, recursive. I will explain this in the project. Okay, recursive, character splitter. Okay, and then we have the semantic chunking. Okay, semantic chunking. And then we have the agentic chunking with the help of LLM. Okay, agentic chunking nothing but we are going to call this LLM for this creating the chunks. Okay, then we have this markdown chunking will be there, unstructured chunking will be there, right? There are multiple chunking strategy will be going to implement. And after that, guys, okay, third component is nothing but the embedding models. Okay, embedding models. Okay, these are the different embedding models. Okay, these are the different embedding models. Let's suppose this is the open source embedding model. Okay, in the open source embedding models, it will sentence transformer. Okay, all meaning LM 006 or 002. Okay, this is the sentence transformer open source, guys. Okay, directly generally we go with the first attempt. When an exploration we go with this open source. But let's suppose they write this different company, guys. Let's suppose OpenAI, right? OpenAI also come up with their embedding model, but this is the paid. Okay, this OpenAI come up with this, but this cost is very much less, guys. Okay, this cost is very much less from this OpenAI. I'll showcase this documentation also. Okay, yeah, OpenAI embedding models. Okay, they come up with this ADA series. Okay, ADA series embedding models, ADA series 002. Then later nowadays they are with the small. Okay, text embedding small and text embedding large. Okay, the text embedding small and text embedding large. The text embedding, and this is the in that we have the two versions. Okay, small, and there is another version is a large. Okay, small and large. Then Google also come up with their embedding models. Okay, Google has also provided, right, different embedding model. So they also come up with this text embedding models. Okay, this is how we can utilize the different embedding models. Okay, then next part is I suppose the fourth component we have vector store. Vector store already we understood, right? So we have the different vector store as let's suppose in memory and cloud based, right? So we have this in memory and cloud based. Okay, so in memory we have this 5S, ChromaDB. Okay, and then in memory as a one there. Okay, and in the cloud we know, right? And the Pinecone is there. Then Azure Cosmos, Azure, right? Azure we have the Cosmos DB is there. Okay, Cosmos DB. Then in the AWS we have this S3 buckets are there. OpenSearch was there initially. Okay, till now this is there. Then we have this Pinecone, then PostgreSQL PG vectors is there. Okay, then AstaDB, Mailvet. Okay, there are the different database also there. Okay, and then after this vector store, there is a different retrieval, guys. Okay, there are the different retrievals also there. Okay, there are the different retrieval strategy will be there. Retrieval strategy will be there. So there are the some advanced retrievals also there, guys. Okay, so we can use the self context retrievals are there, multi-query retrievals are there. Okay, there are the multiple retrievals there. Okay, so you can see self query. Okay, in the retrieval, generally we are going to utilize this, right, vector store as a retrieval. In that we are using similarity search and MMR. Okay, similarity search and MMR. Okay, generally we are going to utilize similarity search and MMR. Okay, but there is advanced retrieval like a self query, right? Self query retrieval is there. The context compression, right? Contextual compression retrieval are there, right? Contextual compression. Okay, contextual compression retrieval are there. Then parent child. Okay, there is a parent child retrieval is there. Okay, and then we have the multi-query retrieval is there. Okay, multi-query. This is the advanced retrieval, guys. Okay, multi-query retrieval there. Okay, so self-query retrieval, contextual compression, parent child, multi-query, right? So there are multiple retrievals also there. Okay, so this how we have this, right? And LLM model, guys, you know, right? We have this LLM models. 6 components, nothing but the LLM models. We have this, right, from the OpenAI. In the OpenAI, we have the GPT based, right? GPT based models, right? GPT initially 3, 3.5, then 4, 4.1, 4.2, right? Like this, 5, then 5.1, then 5.2 is also there, and 5.2 Pro is also there, right? From the OpenAI. And then in the Gemini, right? Google, right? Google also come up with their different Gemini based models, right? Gemini series. In the Gemini series, they have this different models, like we can say mention as a Gemini Pro and Flash model is okay. Gemini Pro and Flash series model. In this, as of now, they have come up initially also 1.5, 1, 2.0, 2.5. Now they come up with the 3, 3.0 also, right? Flash, Flow, Vision models also there, right? Then Meta companies there, right? Meta is also there. Meta is also come up with this different LLM models, right? Then the Meta having this, right? We can say Llama model, guys. Okay, Llama series model. Recently, model is the 4. Marvik Scout model is there. Then Anthropic is also come up with their different LLM models, right? Anthropic also come up with their different LLM models, right? In the Cloud series models from the Anthropic. Cloud 4.5, the Opus and Sonnet model is there. Okay, Opus, Sonnet model is there. Very famous model, right? 4.5, 4.1. There are different LLM models. There are different providers are there. Okay, so now we'll showcase the documentation, guys. Okay, if you see here, if you go to the documentation now, how you can refer this, where you can refer this. Okay, so now you can see, I will showcase this LangChain, guys. Okay, LangChain. GitHub. If you go to the LangChain GitHub, now you will find the different document loaders, different chunking strategy. If you go to the LangChain GitHub, okay, if you go to the library, okay, and if you see here, if you go to the LangChain, okay, classic, and we have the document loader, guys. You can see here the different document loaders are here. Okay, you can see, if you see, go to the init file, and we have the different document loader. You can see, so these are the different document loaders are there. Airtable, right? So Azure data loader, Azure block storage is there, bits text loader is there. Okay, the HTML loader is there, CSV loader is there. Okay, then there are the docs to text loader is there, right? DuckDB is there, the Figma file loader is there. Okay, then Google client loader is there, YouTube loader is there also, Git loader is there. Okay, there are multiple. You can see the JSON loader is there also. Okay, so there are lots of image loader, PDF miner, PDF splitter is there. Okay, so there are the PyMe PDF loader is there, PDF directly loader is there. Okay, PyPDF is there. Okay, there are lots of document loader. Unstructured, we have the different types of unstructured. Web-based loader are there. Okay, so you can read about this. Okay, document loaders. And also we have the chunking strategies. Okay, we have the different chunking strategy. Differ the vector store. You can see here. If you go to the memory, right? Memory. Let me go to the vector store. Okay, you can see the vector stores are there. So we have the Redis. Okay, so we have the AstaDB. Okay, you can see these are the different Alibaba Cloud Open Search Analytics DB, Atlas, Azure Search is there. Okay, so this is a deep lake is there, elastic, and you can see elastic vector search are there. Okay, and there are the different document vector stores also, guys. Okay, you can page vector is there. Okay, so then we can have this. You can see the chroma DB is also there. Okay, 5S chroma DB. You can see the chroma DB is also there, and the 5S is also there. Okay, where is the 5S? Okay, in between you can find the 5S also. Malwares is there. Okay, the MongoDB, MyScale. Okay, Neo4j vectors. Okay, these are the different document loaders, guys. Okay, there are different document loaders. Likewise, we have the different vector stores, different document loader, different chunking strategy. Okay, you can refer this documentation and you can find this. Okay, all these document the different retrievals are there. Memory components will be required. Okay, so this how this embeddings model purpose. We have the different embeddings models also there, right? If you see here, these are the embeddings models are there. Okay, Bedrock embeddings also there, Azure embeddings models are there, GPT-based embedding model, Google-based embedding models are there. Okay, so these are the over Llama-based models are there, right? So lots of embedding models also PC there. Okay, so this is how we can refer this and you can start implementation also this. Okay, so these are the different. This is the documentation, guys. You can definitely refer this documentation and understand this. Okay, what are the different document loaders are there? And this is LangChain, right? So LangChain has provided we can directly utilize this document loader for this implementation purpose. Okay. In the tomorrow session, what I'll do? So tomorrow session we are going to implement this project, guys. Okay, rack-based project. We're going to implement this rack-based project and we try to deploy this on the cloud. Okay. So any questions so far? Yes. No one? No questions? Okay, I will share this document, guys. Okay, I will share this. Okay, you can see is how to create this AWS account. I will share this again today. Okay, some of the new learners are there. I will share this syllabus also, right? This is the some of the batch I generally conduct here. You can see here the recent batch I'm going to convert a new batch. I'm going to start artificial intelligence. Okay, and you can get the content of the syllabus. Okay, you can see here the upcoming batch. This is the artificial intelligence batch. You can see here the course content is there, right? You can go to the course content. You can just understand what are the syllabus I'm going to cover in this new batch. Okay, so this is the most of the syllabus I will cover in the Python, statistics, machine learning, deep learning, NLP, generative AI, agentic AI, and AWS and Azure cloud also, right? So this is how I'm going to cover, and you can walk you through, right? So just go through this syllabus, right? Understand the syllabus, okay? That will be helpful, and do join this. Further, you can say I will share this link, WhatsApp community link. Okay, so this will be helpful for you guys. Okay, so this will be helpful for you. So let me share this. Okay, I will share this link. Okay, okay. Thanks, guys. Okay, for your feedback. It's really appreciated. Okay.
Sure. Hello.
Yes, yes.
Sorry, sir, I disturb you. Like, is there any upcoming bench like for MLOps and DevOps profile?
Uh, Actually,
MLOps profile.
MLOps not generally I don't contact for the MLOps. Okay. DOps there is a DOps. You can see Azure. The Sunil sir is conducting this Azure or AWS DOps. Ankit Narula. These are the different trainers are available for this Azure and AWS also, right? DOps. You can just check here the courses here. You can see go to the course. You can find this, right. And the Azure DOps is there. Then you can see the Azure AWS DOps, right? Sunil sir, right? And then you can see the some of the different batches is going on. I generally conduct this generative AI and I will generally conduct this artificial intelligence, guys. Okay, this two batch I generally conduct here. And if you if you go to the syllabus, right, what is the syllabus I have covered in the previous batch, you can just go through it one more time and understand, right, what is the syllabus I have covered in this total, right, artificial. This is batch I recently covered. Okay, and you can see the day by day syllabus I have covered. This initially 1 month Python will be there. Then we are going to understand the statistics. Okay, advanced Python will be there. Statistic will be there. Then we are going to cover this machine learning. We are going to start different algorithm, different operation, right? Different techniques in the machine learning. Then we are going to build the project. Okay, different algorithms we are going to build up. Then we are going to understand different KNN, machine learning, decision tree, right? Random forest, XGBoost. And then we are going to start the NLP. Then we are going to some of the project will be there in the NLP deep learning. Okay, and then we are going to start with the encoder decoder transform architecture and LLM models, right? Generative AI, we are going to start. What is the generative AI? What is the different LLM models, different LangChain frameworks, prompt engineering, RAG architecture, it's a deployment. the project, evaluation of this RAG architecture, then agentic AI we are going to start, right? So this complete whole package will be there in this course syllabus. Okay, just go through it, understand the course content, and accordingly you can decide. Okay, this is the generative AI syllabus. Okay, I generally take these two batches, generative AI and this artificial intelligence. Okay, so any doubt, any question, guys? Okay. Okay, thanks for your feedback, guys. Okay, really great. I really appreciate it. I hope you understood, right? Any challenges, guys? Understanding the things, right? So I hope you got the clarity, right? How we can implement this RAG architecture. In the tomorrow session, what we'll do? So we're going to implement this practically, guys. Okay, we are going to create this practically implement this exploration part. Then we are going to create the source code, and then we are going to deploy in the Azure cloud. Okay. Okay. Thanks. Okay. Great, guys. Okay. So we'll see you tomorrow. Have a great day. Bye. See you tomorrow. Okay, I can say one doubt is there. Any prerequisites or knowledge required? Yes, Neil. Okay, there is a prerequisite is the Python knowledge. Okay, but I will cover this Python knowledge in the this session itself. Okay, so there is a only prerequisite is the Python knowledge. So I generally start this AX sessions with this Python. Okay, 1 month I will take this Python. Okay, hands-on Python. Once we are good with the Python, then we can move on to this statistic, machine learning, and then subsequently deep learning, NLP, and generative and agentic AI. Okay, so do not worry. I'm going to cover this all from the scratch, from the basic case. Okay, so don't require. You have to for joining this course. We don't have to do any extra course. Okay, so I will cover in this its syllabus. This in this syllabus itself. Okay. Okay. All right. So we'll stop here, guys. Have a great day. Bye.